And number 9, we have an A of 3, a B of 1/4, H is positive 2, and K is equal to 1. So this is an exponential decay function because the base is a fraction between 0 and 1. Okay, the asymptote is at y equals k, and our k is 1. So at y equals positive 1, we can dash in the horizontal asymptote on the graph. Okay, then the domain of all exponential functions is the interval of all real numbers, so negative infinity to positive infinity. The range, because there's been no reflection in the x-axis, is going to be from that horizontal asymptote of 1 up to positive infinity. So we're going to get the anchor points from our parent graph where the base is 1/4. So the anchor points are 0, 1, 1, B, which is a 1/4, and then negative 1, the reciprocal of B, and the reciprocal of 1/4 is 4. Okay, then we're going to multiply the y value by A, which is 3. So our x's all stay the same in those ordered pairs, and then 1 times 3 is 3. 1/4 times 3 is 4/3. Oh no, it's not. Let's fix that. 1/4 times 3 is 3/4. I have that upside down. And then 4 times 3 is a positive 12. Okay, next we're going to do our horizontal translation by adding h equals 2 to the x values. So 0 plus 2 is 2. 1 plus 2 is 3. And then negative 1 plus 2 is 1. Okay, then our vertical translation comes from the k. So we're going to add k equals 1 to all of our y coordinates. So the x's all stay the same. And then 3 plus 1 is 4. 3/4 plus 1 is 1 3/4, or 1.75. And then 12 plus 1 is 13. So we'll come over to our graph and sketch these transformed points. So 2, 4, and then 3, 1.75, 1, 13 is way up here. And then to get the coordinates of 2 more points to guide our curve, there's no sense going to the left of positive 1, for example, getting the y-intercept, because we're already at the top of our graph. And if we go the other direction, then let's see, 4 we could put in. We're going to get something really close to our asymptote at 1. So that's a 3, and then 1/4 to the 4 minus 2 power plus 1. And 4 minus 2 is 2. 1/4 quantity squared times 3 would be 3/16, plus 1, which is 16/16, would be 19/16. And let's put that in the calculator. 19/16 is equal to 1.18. So that would be approximately 1.2. So this would be 19/16, which is approximately 1.2, and that's really, really close to that asymptote. We could also pick a point that isn't a whole number. We could pick, say, 1.5 to get a guide point between these two. So if we put in 3/1/4 to the 1.5 and then -2 + 1, and we can evaluate that in the calculator. So 3 and then, oops, can't see, 3 times 1/4 raised to the 1.5 minus 2 power plus 1 is equal to 7. So we can plot that point, 1.5, 7 on the graph. And then we have enough guide points that we can sketch a pretty accurate